Okay, so we're going to do some binomial expansion. Sometimes you'll find this under binomial theorem. What it is taking a binomial and multiplying it to some, or raising it to some exponent. So we're raising this one to the third power. I picked a little example to start just so that you can see what we're talking about. Now, one way that I could actually do this is to go ahead and, actually multiply them together. So you'd have to write them out probably, unless you can keep track of that in your head, but that's kind of crazy. I'm going to multiply these two together first, so it'll be x squared, and that'll be plus 2x. Plus 2x will have a plus 4x plus 4, and then we're going to multiply that by x plus 2, and so then we get an x to the third plus 4x squared plus 4x, and then I'm going to go back and do these ones, and I'm going to do 2x squared plus 8x plus 8, and then I'm going to add them up. So x to the third plus 6x squared, 12x plus 8. Okay, so that's one way we could get that accomplished. And you can see if I was raising this to the fourth power, the fifth power, that would get quite tiresome to be multiplying those out all the time. And these are, relatively small numbers, easy to multiply, and it was already kind of annoying. Okay, so what we're going to do is, hopefully you watched the video on Pascal's triangle, or you know about Pascal's triangle if you didn't. And so what I'm going to do is I'm actually going to write out Pascal's triangle to the third row, and I'm going to choose 3 because this exponent is a 3. Now remember, I'm counting this as the 0 row, 1, 2, and so I'm calling this one the third one. Okay, so when I say the third one, I'm talking about the one that has a 3 as the first, non-1 number. Okay, so here we are. Okay, now this is what I'm going to do. My binomial expansion, and again, we can talk more about it, why that is and whatever, and but I want to keep the video kind of short so people will watch it. So what we're going to do is we're just going to get right to it. Now I want you to look at what happens here. You have a cube, a square, to the first power, and then to the 0 power, because that's like x to the 0, which would be 1. As they're going down in that order. Now, what you can't see is something else is happening, and maybe I should have done it with numbers, with letters. So let's just do this one quickly. So this would be x squared plus 2xy plus y squared. So this is a very, very small one, but hopefully you'll be able to see what I'm talking about here. Do you see how this is x to the second, and this is y to the second? So they are both to the second power. The first and last terms are to the second power, right? But this term actually has a degree of 2. So remember, if you're talking about just like one monomial, the degree of the monomial is the sum of the exponents. So since both of these are 1s, that's also a 2. Now you can't really see it in here, but I'll show you it in a second that it's actually true here. That all the exponents, like if you were to write this out exponentially instead of multiplying out the numbers, you would have, they'd all be to the third power, just like all of these are to the second power. So let's take a look. When I'm going to use my binomial theorem, I'm going to use these 4 numbers. So I'm going to write them here so I can see them. So that's the row on Pascal's triangle I'm going to use. And what I'm going to do is I'm going to know that I'm going to start with an x to the third because he's the first one. And I'm actually going to end with a 2 to the third, just like I ended with the 2 to the y. I know that that's going to happen in the thing. And then the ones in the middle, what is going to happen here is this one will go down by 1. It'll go x to the second. And since this has 2 to the 0, we'll have a 2 to the first. And this one here will go down 1 more. This will be x to the first, and we'll have a 2 squared here. Okay? But that won't be all that I'm going to have. So these are my terms. I'm starting to write out my terms. I'm also going to have these numbers from the triangle. So this one I'm going to multiply by 1, which obviously doesn't change anything. This one I'm going to multiply by 3. This one I'm going to multiply by 3. And this one I'm going to multiply by 1. Okay, and then I'm going to add these all together. Now take a look at what happens. This becomes x to the third plus, well, 2 times 3 is 6x squared. This will be a 4 times 3 is 12, and this will be an 8. And you see how it gave me the same exact numbers as up here? Pretty cool, right? So instead of doing out all that math, I just needed to know this, and I needed to write these ones from the third power descending order, and these ones, you can either think about it as going from this way descending, or this way ascending, like from the 0 power to the third power. So let's take a look at one more. So let's do 2x plus 3y. Let's do something small. To the, let's do 4th power. Okay, so let me zoom out a little bit because I keep going off the page here, so just so you can see. Okay, so the first thing that I need to do is figure out my row in Pascal's triangle, and since I have it written here, I'm just going to do it here. It's going to be 1, 4, 6, 4, 1, right? So this is the row on Pascal's triangle that I'm concerned with. 1, 4, 6, 4, 1. Okay. Oh, actually, you know what? Let's make this a negative because that's interesting to see too. So you notice this one was positive. So obviously when I multiply things together, they're going to be positive. I'm going to show you how I'm going to deal with this negative. So if this is the only example we get to in this video, I'm going to have to write negative 1. Okay. So now again, when you read in some books, they tell you to alternate the things. I'm going to show you, you don't have to worry about alternating. I'm always going to be adding them together. But the first thing I'm going to do is start to write these. I'm going to write them to the 4th, and then I'm going to make my way down, right? I'm going to have 2x to the 3rd, 2x squared, 2x to the 1st, and then I'll have a 2x to the 0. But I'm not going to write him because he's 1, all right? Now the next thing I'm going to write, so that's these guys taken care of. The next thing I'm going to take care of are these guys. But I'm going to think about it as a negative 3y because he's a negative 3y, okay? So it's negative 3y to the 0, the negative 3y to the 1st, the negative 3y squared, the negative 3y to the 3rd, and then negative 3y to the 4th. So now I have taken care of those. Now the only thing left to do is to take care of Pascal's triangle. So the first one's going to be multiplied by 1. I'm not even going to write it. Well, I guess I will for... Okay, and then it's times 4, then it's times 6, then it's times 4, and then it's times 1. And then I'm going to add these all up. So, okay. Now again, you can use your calculator from here. You can do them in your head. Most of you probably know what 2 to the 4th is, right? Again, but if you don't know how to do them on the calculator, it's 2. You hit the 2, and then you want to hit this little caret thing. It's hard to see it's under the clear button, so that he looks like this. 2 to the 4th. And so obviously that's 16, because 2 times 2 is 4, times 2 is 8, times 2 is 16, and there he is. Now this one, what are we going to do? Now it's 2 to the 3rd is 8, right? So we're going to have 8 times 4, and then we're going to have times negative 3. Because it's negative 3, right? So now again, remember when you raise these to the 3rd power, you're raising both of them. So this is actually 4 times 8x to the 3rd times negative 3y. So when you multiply all that together, well, let me write it further down here so I can write up here. We get negative 96 when you multiply all the numbers together. You have a x to the 3rd and a y. And you see how if you add these together, you're going to get a 4? And you got a 4 here. Oh, I forgot my x to the 4th. How did I forget that? And you have a 4th here. And actually, do you see how the 2 is raised to the 4th also? You could have wrote it as 2 to the 4th. And it'd be the same thing. All right, so let's take a look at the next one. Now this one, we're going to have that 6. This will be 2 to the 2nd, which will be 4x squared. It'll be negative 3 squared. So what's negative 3 times negative 3? Well, that's a positive 9. And then I have to multiply these together. Let's look here. We're going to get an 8x. I'll just multiply these two together. Negative 3 to the 3rd. So that'll be, negative 3 times negative 3 is a positive 9 times another 3. Negative 3 will be a negative 27 y to the 3rd. And then this one, when you multiply -3 and -3, you get a positive. -3, you get a negative. Another negative, you get a positive. So that will be a positive 81 y to the 4th, right? So again, now all you have to do is multiply this stuff together. So you get a 6 times 9 times 4. That gives you a 216 x squared y squared. And again, I put a plus here because they're all positive. This one's going to be an 8 times a negative 27. And of course, that'll give you a negative 216 x y to the 3rd. And this will be 81. It's a positive. And it alternated the signs for me already because I kept the negative with the 3 and I just did what it said rather than trying to figure out which ones are positives and negatives. Always add them together and just consider this last term negative if you're going to do that. And so this is called expanded, or it's multiplied out, whatever you want to call it. But usually they'll use the word expand, I think. And again, you don't really need the 1 there, but that was so that you could see that it was to the 4th. 2 plus 2 is 4. 1 plus 3 is 4. 4, 4. So they're all the terms have, to the 4th power in them. And that's how you would use Pascal's triangle to do binomial expansion. And again, you could also use and choose R if you didn't want to draw out the row. You know that these numbers are, 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4. So the other way you could have done it, instead of writing a 4 here, you could have said, so if we're taking this one, I could have said 4 choose 1. So this would have been 4 choose 0 times your x to the 4th. This would have been 4 choose 1 times your 8x cubed is negative 3y. And you could actually literally type that into the calculator if you didn't, if you're so far down Pascal's triangle, or if you're too lazy to write it, or whatever it is. I just think these are hard to punch into the calculator to do a bunch of them. So it's 4 choose 1 times 8. I meant to hit times and I hit. Oh, I always messing it up. That's what I mean. To me, it's easier just to do it by hand because I always screw up the calculator somehow. So times 8 times negative 3. And there you go. I get my negative 96. Okay? So there you go. That's how you do out your binomial expansion. Not too terrible. Remember, though, sometimes they'll ask you to find like the 3rd term in the sequence in your expansion or whatever. Remember, when you're expanding, this first one is using a 4 choose 0. So if you were finding the 1, 2, 3, this term in your binomial expansion, you want to use 4 choose 2. This is going to be 1 less than the one that you're looking for, right? Because you're starting counting at 0, 0, 1, 2. Okay? Just like, your sequences. Think about it that way. All right, guys, that should be enough to at least get you started.